ただいまよりテクノロジートラックを始めさせていただきます。ここからは DevOps on AWS 継続的デリバリーと AWS 開発者ツールへのディープダイブと題しまして Amazon ウェブサービス DevOps 担当事業開発マネージャークリス・マンスより講演させていただきます。 Please welcome クリス・マンス。
こんにちは。私の名前はクリスです。よろしくお願いします。And that's about as much as I could Google quickly before this talk and about as much Japanese as I know today. But thank you all for coming. Arigato. I appreciate you being here today. Today's topic is a big part of DevOps called continuous delivery. In my role here at AWS, I focus on DevOps as a transformative part of how we're seeing the industry change and how it's adopting the cloud and how businesses are becoming more agile. And so I work with a lot of companies around the world on understanding what DevOps is and how DevOps applies to them. I also want to say thank you again on behalf of AWS for attending this event this week. I travel to many of these events around the world, and I have to say that the energy and the intelligence and the excitement here in Tokyo has been unbelievable. So again, thank you on behalf of AWS. So why are we here today? Essentially what we see in today's world is that software moves faster than ever before. Startups can now take on large enterprises in established areas with much lower investment at a much greater speed than ever possible. Getting your software into the hands of your users has become much simpler than ever. And then lastly, it's your ability to move quickly that's paramount to your ability to fend off competition and to grow your business. If we think about how software delivery used to be, just a couple of years ago, you would typically have to walk into a store, find the package for the software that you needed, go back home with it, and then install it on your computer. If we think about how software is delivered today, pretty much almost everyone in this room probably has a smartphone and a smart device at home and other connected devices. Software can be brought down onto these devices almost instantaneously, and so the blockers to getting new software and accessing new applications have been greatly reduced. We also have devices today, things like watches, the Amazon Echo, and even cars that are downloading software to make themselves better. It was only a couple of months ago that Tesla was able to push out software to cars for people such that they woke up one morning and all of a sudden their cars could drive themselves. These owners of these cars didn't have to do anything to get this software except own the car. So it's a very different world compared to what it used to be even just 5, 6, 7 years ago. You have to remember that smartphones like the iPhone and Android are only about 8 years old now, so it's still a pretty new technology in the world of technology. So what do you need to move fast? There are a number of tools as well as techniques and practices that you will need, and obviously we'll be talking about one of those today. You need tools to help manage the flow of your software development release process. You also need tools to properly test and inspect your code for defects and potential issues. Today, if you release an application that has a serious bug or doesn't work, because of the low friction for people to get your software, there's incredibly low friction for people to get rid of your software. So making sure that you're releasing a quality product is even more important now. And then lastly, tools to actually deploy your applications, whether they be web-based applications, APIs, mobile applications, or applications that might live on some sort of a smart device. Oops. Sorry. But first, we need to think a little bit about the software process. And I'd like to make the analogy to creating donuts. Donuts, very simple, very small, very easy to consume. When you're making a donut, You're not making a 5-course meal. You're not building a car. You're not building a rocket ship. You're making this small little circle of happiness that you get to consume. And I like to think that in today's world of DevOps and doing agile iterative development, you want to think about making donuts versus those other things. So we see release processes having 4 major stages. First, a source stage, then a build, then a test, then a production or an out to your customer stage. And across these, there are a number of steps that you will typically take. So in your source stage, this is pretty straightforward, right? This is where you would commit your code to some sort of a code repository. Maybe other members of your team have reviewed it. In the build stage, depending on the language that you're using, you're probably compiling your code or packaging it somehow, running things like unit tests against it, running things like style checks against it, making sure that there is some degree of quality assurance at that level. In the actual test phase, this is where you would take your application and actually act against it. So if it's a web application, you're running it on a web server, you're doing live integration tests. If it's a mobile application, maybe you're using a service like AWS Device Farm to be able to test that application. This is where you're really looking to make sure that the application performs the way that you want to. And then in the last phase, our production is actually getting it out to our customers. And again, depending on the application, there's many ways that you might do this. Similarly, there are several release levels that correspond with these phases. First one, continuous integration, the act of iteratively working on your code, continuously committing it to a central code repository, and then having automated builds and tests run against that code. Building on top of this is continuous delivery. The act of then taking that built code, doing further tests, and again, proving out that you have a quality product. And then finally, putting all these together is continuous deployment. Continuous deployment is the idea that you have automated the full process from committing code to pushing that code out to your customers. What differentiates continuous delivery from continuous deployment is the concept that there is some sort of a gate, some sort of a blocker that stops that full automation. And so I think this is a term, or these terms sometimes get mixed up in the industry, and that's why I want to be very clear about how we define them here at AWS. And today we'll be focusing just on the act of continuous delivery. So continuous delivery is not something new. It's not something that we at AWS invented, but it's something, again, that the industry is moving to today very rapidly. So what are some of the benefits of continuous delivery? We see a number of benefits, but I think that there are 4 that we very much want to highlight. The first is around automating the software release process. By automating this process, you can remove a lot of the fear and stress that comes from actually doing this process if you were doing it manually. You can also then improve developer productivity by automating this process. Developers will be able to find and address bugs more quickly. That allows them to deliver code more quickly, and that allows you to gather feedback from your customers more quickly. So it's very much a virtuous cycle. And then lastly, obviously, the ability to then iterate and deliver updates to your customers at a much faster pace. So what I'm going to do is step back a little bit, tell you some history of how development at Amazon has changed over the last 15 years almost. When we go back to 2001, if any of you shopped on Amazon at that time and you interfaced with the website, you were interfacing with a large monolithic Perl application. Almost all of the workflows, all of the things that you did as a user went through this one massive Perl application. And we realized as we were growing as a business that this wasn't going to work for us. And so we needed to make some changes. And so we did a number of things, and this topic is something that we could actually spend an entire session on. But what we resulted doing was breaking down our monolithic application into what we call microservices, and then breaking down our development organization into what we call 2 pizza teams. Essentially the idea that any problem that exists inside of our product or any product that we're trying to build will be built by a team of people, typically 6 to 10 people. The idea being that they could be fed at lunch by 2 pizzas. And so this has been a very successful model for us, and one that we implemented in 2001, and that continues on to live inside of Amazon today. And so we like to be very introspective at Amazon. We like to look at ourselves and say, where can we improve? What can we do better? And so while we were able to release product much faster under this model, we were always looking at how fast we were going and thinking that we could be going much faster. So in 2009, we actually ran a very big study on how the development process at Amazon was behaving, how essentially it was working for us. We found some pretty interesting things. The biggest thing that we found is that we were just waiting. Essentially what happened is we had our product teams that were writing code, and then waiting for someone to build that code, then waiting for someone to deploy to a test environment that code, and then eventually after testing, that code would get deployed out to production. And this took us a lot of time. But what was interesting is that the actual work being done by people was minutes. But the handoff time could be days. You know, someone had to put something into a ticketing system, you had to wait for someone to act on that ticket, and so that handoff really dragged out the process. And so it was taking us weeks to release code. And what we really wanted to do was streamline this process, because we understood that the actual work being done by a human was minutes. So if we removed all of the gap in the middle, what it meant is that our ability to deliver code theoretically should be able to be shrunk down to hours. And so we viewed this as a technology problem. We said, what can we do with our technology stack to help solve this problem better? And so what we did, and what we do often, is we built tools to help make this process much easier for our developers and to really help us raise the bar in terms of the quality of the product that we were releasing. So one of the products to come out of this is a product called Pipelines. Now, Pipelines is a tool used inside of Amazon by almost every development team. No matter what product they're building, whether it's a web app, a mobile app, an app that gets installed on a physical device like Kindle, all of those teams are using pipelines to help orchestrate their delivery process. And so what Pipelines really does is it aids you in continuous delivery, being able to give you the ability from check-in out to production deployment with all of the various steps that you need in the middle, helping our developers ensure higher quality. And we found a number of benefits from this. We were able to release features much faster now because we were able to shrink all that waiting time. It was then far safer because we were automating the process and removing some of the human element. We were able to make it consistent and standardized. So as a developer inside of Amazon, you could go from one product team to another product team, look at that other team's pipeline, and instantly understand the workflow involved in building their product. And then lastly, we made this a visual product because it's much easier as a developer to understand a visualization of a workflow than to have it be something maybe that's text-based that you have to really kind of read through and understand all the manual steps. So this has led to some really great capabilities that we have inside of Amazon. And I'm going to share with you an interesting fact from 2014. So in 2014, across the thousands of development teams that we have at Amazon that are building microservices, very small components, that are practicing continuous delivery, again, really automating this process, and then deploying code across numerous environments, things like dev, staging, prod. What it means is that in 2014, we did 50 million deploys. And these are typically deploys that would go from anywhere to 10 to maybe hundreds of hosts or instances inside of our infrastructure globally. That works out to be about a deploy per second. And I could say that we've only gotten faster since 2014. So I had mentioned that we like to be very introspective about how we are performing as a business. And so every year we survey all of the technology teams inside of Amazon to understand what's working for them, what's not working for them, where we could find improvements. And so in the same year that we have this 50 million deploys fact, we also found something really interesting, that pipelines was the only tool that we could statistically correlate to happier developers. Because we measure happiness of developers via this survey, we're able to figure out that the teams that were using pipelines heavily to heavily automate their delivery process were, again, statistically happier than those that weren't. And because of this, we are now encouraging every team to use pipelines to fully automate this process. When I found out about this fact, I found it very shocking. And really what it reflects is that continuous delivery leads to happier developers. Now, I had mentioned other benefits before: safer deployments, quicker deployments, standardization. Those are all very good business metrics and business values to think about. Happiness is not something that we typically measure inside of engineering organizations. But here we have an actual value or a fact that we can tie around continuous delivery leading to happier teams. So this is, again, about the internal tool that we have at Amazon. What we like to do at AWS, as many of you probably know, is take things that we've built inside of Amazon and launch them as AWS services. So last summer, we launched a service called AWS Code Pipeline. Code Pipeline was built taking the lessons that we had learned from pipelines internally and then extending it out to our AWS customers, such that you can automate your continuous delivery process, again, everything from check-in to production deploy, and be able to visualize it and model it no matter what your application might be. So whether you are building a mobile app, a containerized app, a Lambda app, a web app, you should be able to plug in pretty much anything you want to Code Pipeline. And that pluggability is one of the big components of the service. We make it very easy for you to plug any tool you could think of into it. So some of the benefits about Code Pipeline. It has a configurable workflow that you as the developer can configure based on your application's need. It's very easy to integrate. We have two different methodologies for integrations. I'll talk about that a little later. You'll see, again, improved quality by practicing continuous delivery. So while the tool itself doesn't do anything to enforce better quality, this is something that will be a side effect of using a service like this. It allows you to greatly speed up the delivery via this automation. And the other thing is that it allows you to get started very quickly. Because this is a GUI-based tool, you could very easily go into the web console and create a pipeline. And I'll show you an example of that as well a little bit later. So let's take a look here at what Code Pipeline actually looks like. This is an example visualization of what you would see in the console if you were creating a pipeline yourself. Oops. Okay. So this is a pipeline. Pipelines are then made up of stages. Stages are made up of actions. And then between stages, we have transitions. So transitions that connect you from one stage to another. We allow you to run parallel actions inside of a stage. We also allow you to run sequential actions inside of a stage. So based on this, you can very easily model out a very complicated workflow for building, testing, doing integration tests, doing performance tests, or doing load tests against an application. Let's take a little bit look at what the workflow looks like when you're using Code Pipeline. So I'm a developer. I'm personally actually a very poor developer, but in this case, I'm a developer. I've committed some code to GitHub, and I've configured my Code Pipeline to use GitHub as a source for my application. Code pipeline will be polling GitHub, looking for changes. When it sees that there's a change, it will take my code and it will put it into S3 and create what we call a source artifact. From here, the source stage is finished, and now I'm good to go on to my build stage. In my build stage, I'm going to use Jenkins to compile my application, which is a Java application. So we have an open source plugin for Jenkins that you can use with Code Pipeline. That plugin will poll Code Pipeline. So it's polling Code Pipeline looking for work. When it finds work, it will take that task. It will acknowledge that task. It will then go and pull down my source artifact, do the work that it needs to do, in this case, compiling my application. It will then create a build artifact, which it will place back into S3. And then the Jenkins plugin inside of Jenkins will tell Code Pipeline that it has completed its task. And then we're on to our deploy. In this case, I'm going to make use of Elastic Beanstalk to deploy my application. Great service for very easily deploying web apps. So Code Pipeline is going to find where the build artifact is. It's going to tell Elastic Beanstalk, here is the build artifact, go and deploy it. And then Elastic Beanstalk is going to do the actual deploy. What's interesting about this is that as a developer, all that I did was write and commit code. After that, Code Pipeline interfaced with 4 different services. 2 of them, one of them an external service, GitHub, another one an open source tool, Jenkins, and then 2 other services which happen to also be AWS services. And there's many different options that exist in this ecosystem. We have a number of partners today that exist across a number of different categories. And actually, for those of you in the room who might work for a company that might fit into the continuous integration or delivery space, we would love to hear from you about integrating with Code Pipeline. We're very much trying to grow this space of tools. We also have a number of AWS service integrations. And I'm really happy to say that OpsWorks was integrated just this morning into Code Pipeline, literally about 5 hours ago. So it's very new, but very exciting that now Code Pipeline can deploy across many different AWS services for running your applications. Now in the middle here, I have AWS Lambda. What Code Pipeline can do is it can invoke Lambda functions. So it has the ability to call a Lambda function to perform work. What's exciting about this is that via Lambda, you could do almost anything that you could think of. You could call another API. You could run an actual process inside of that Lambda function. Another thing you could potentially do is use Lambda to call the run command service and then execute a command on a server somewhere. So it's literally limitless possibilities for how you might shape your pipeline. So let's talk a little bit here about what it's like to build a pipeline and go into it. And so for this, I'm going to attempt to show you a demo. I want to say quickly that doing a demo live is a very risky thing. So my apologies if something goes wrong. I've tried to pray to the demo gods today, but I'm not sure that they heard me. Fantastic. So we see here that I have the AWS console opened up to Code Pipeline. And I've cheated a little bit in this demo in that I've already created a number of resources that I'm going to build around my pipeline. But what I'm going to walk you through is just the pipeline bits. And you probably understand where the other services come from. So I'm going to create a new pipeline. We'll call this one Hello Tokyo. I'm going to select a source provider. In this case, I'm going to choose GitHub. And now I've already got my credentials stored for GitHub, so it just has to go and pull a token. And then what it will do is it will automatically populate a number of different repositories that I have in GitHub. It will then pull down the branches for that repository. Now from here I get to choose a build provider. So we have a number of different build providers that are integrated with CodePipeline today. And I'm going to choose Solano CI, which is a third-party hosted option for doing CI. It's a SaaS offering, a lot of great capabilities, and they have integration directly into CodePipeline. In this case, I have to authorize CodePipeline to talk to Solano. And again, I have an existing account. So clicking through some of the things here. Now I get to choose a deploy step for what's called, in this case, a beta stage. Now the web console forces certain constructs upon you. At Amazon, we talk about our environments like beta, gamma, and so forth onto production. So we have this concept of beta in here. You could think of it as dev or test or staging, and it's just the way that it works in the console. But if you were calling this via the API or CloudFormation, you could call it whatever you'd like. I'm going to integrate my beta stage with Elastic Beanstalk. And just like with my source stage and my build stage, CodePipeline will go and reach out to that service and find existing resources that I have. So I'm going to pick my application that exists. I'm going to pick the environment name. Oops. And then I can go forward. You have to give CodePipeline an IAM role so that it has access to all of these services. Again, I've cheated here because I already have an existing role. Great. So now I've configured a source, a build, and a beta stage or a deploy stage for my pipeline. I can review it very quickly and then create this pipeline. So this is just telling me that my pipeline's been created, and it's actually now going to kick off a deploy of my application automatically for me. Now I can actually tell it to hold off and disable going past my source stage. And actually I can go and enable or disable transitions wherever I need to. Now one reason that I might want to do this is I might want to go and now do further configurations of my pipeline. So now I'm going to go and edit this. And I'm going to add another action to my beta stage. In this case, I'm going to interface with another third-party tool, a testing tool called Aws Inspector. Now, Aws Inspector is a third-party tool that allows you to do transactional web page testing. So it can look at a web page, click on a button, fill in a field, click on another button, essentially automate the tests that you would do for testing a web interface. Again, because it's a third party, I have to connect to it, and so my credentials are already cached. And I'm going to choose the test that I have configured already. And add my action. Great. I'm going to do one other thing here before I finish this. That's to add one more stage. So in this case, I'm going to add a production stage. And I want to add an action to then deploy to that production stage. I give it a name. I pick the service that I want to interface with. Again, I'm already integrated and able to talk to code deploy, so I picked code deploy. So I find my application that exists. I find my deployment group that exists. Oops. And I tell it my artifact for doing the deploy. And great. And now I'm clicking through and saying save. So what I've done here is add in, after my first deploy, essentially an integration test. If that integration test passes, then it will do a production deploy for me. So what I have here is first build, which if the build fails, my deploy stops. And then an integration test, where if the integration test fails, my deploy stops. Essentially giving me two different types of gates, if you will, to this process. And I'm actually just going to go to this existing one that I have. And so you can see here, this is an example of this pipeline fully executed. So that's what the green on the left side represents. And we can see here the time frames that have happened, the services that I've interfaced with, and a whole bunch of other information about this execution of this pipeline. And so what I really wanted to highlight here was just how easy it is to get started and how easy it is to plug in various different components to your pipeline. So I'm going to go back to my presentation here. Great. So I had showed you an example of the pipeline. One thing that I didn't show you is that all of the blue links that you saw, you can actually click through to go to the service that it represents. So if I had integrated Code Deploy, Elastic Beanstalk, Solano Labs, and then Ghost Inspector, I can actually link into the results from those steps, or those actions, I should say. So let's talk a little bit about build and test aspects of your application. Building your code is very much relatable to the language that you're using for your application. Some languages need to be compiled, many languages don't. If you're using Docker, you might need to build a Docker container or a Docker image as part of your deploy. And so as part of a build step, again, this is another place where you can check to make sure that your application is capable of being built. This is one of the most basic levels of checking that your application runs. And again, this is something that you want to automate and do frequently. There are some companies that will do nightly builds or weekly builds. That iteration cycle is way too long. And so you want to be doing this very, very frequently, again, as part of continuous integration. There's no building required for many other languages, though. So for languages like PHP or Node.js or Python, you won't need to do a compile. In this case, this is code that would just be able to be deployed directly out onto a host. When you think about testing your code, this is another topic that we could spend all day talking about. You want to confirm, obviously, that your application functions the way that you're expecting it to. But you also obviously want to catch errors. You want to look for errors in terms of user input, in terms of how clicking through certain aspects maybe of a UI might cause an application to break. You might also want to test for standardizations of a code format. In large organizations, having a code standard could be a beneficial aspect that testing against can actually provide really good information. You also want to reduce any sort of logic bugs inside of your application. Typically, this might be done via unit tests at a very low code level to confirm that your application is performing properly. And then lastly, this is also a great space to make sure that your applications are secure. Today we have a service called Aws Inspector that allows you to look at your code, or looks at your application and your infrastructure, and give you a report based back on the security of your application. And so that's something that you would definitely want to involve as part of this continuous delivery process. So when it comes to deploying your applications, you have many different options today. One service that interfaces directly with Code Pipeline is a service called Code Deploy. Code Deploy is also an example of a service that is based upon something that we had internally at Amazon called Apollo that we then made into an AWS service. So with Code Deploy, you have an agent that you install on your instance. And this could be Linux, it could be Windows. You can actually run this off of AWS on premises potentially. And it doesn't really need to know much about your application. It doesn't care what language you're using. It just allows you to very easily deploy your application. One thing that it does require is an instruction file to tell that agent what to do. So we call this an appspec.yml file, and there are a couple of different structured areas to this file. So you can see examples of these here. The first is where we have a pairing up of source and destination for files. So we can actually, instead of just moving our files to one directory, we can move some files to one directory, some files to another directory. Maybe we want to place a configuration file using this tool. That's something that you could definitely do. We can then set unique permissions across all of that data, depending on what permissions needs we might have. And then lastly, we have this capability called Lifecycle Hooks. With Lifecycle Hooks, you can run scripts or commands throughout the deploy at certain points to automate certain tasks. So you could detach an instance from a load balancer, install your code on it, test that code on that host, and then reattach it back to a load balancer. And there's, again, pretty much anything that you could run inside of a script you could do here. One of the other capabilities of Code Deploy is that it enables zero downtime deployments by allowing you to specify a speed at which you deploy. So instead of deploying to the whole pool of hosts at once, you can actually specify any integer or percentage value with which to do that deploy. And so this can allow you to reduce any sort of impact that your customers might feel from a deploy. And traditionally, this is an area that people struggle with the tooling around. Another component of Code Deploy is how we figure out what instances to deploy to. So we allow you to specify a deploy group either as a tag-based group of hosts or as an auto-scaling group. And when you use it with an auto-scaling group, when a new host comes up and the agent is running, it will actually go and perform the most recent deploy that happened to that auto-scaling group. So this allows you to very easily have your application installed on hosts inside of auto-scaling. So we've talked a little bit about pipelines today, code pipelines. We'll talk about the last aspect here, which is kind of the most important one, which is getting your application out to your users. So launching to production, there's a number of things that you would want to think about. The first is the impact to your customers. What is happening when you deploy this application? Is your site getting slower? Are there more errors? Are there bugs that you maybe didn't discover that might be showing up in your logs? What is the impact to your infrastructure? Has the CPU load gone up higher? Are there many more database queries? And then lastly, what is the impact to business? Did you deploy a change to the checkout page and now nobody can buy products? That would be a bad day. And so how can you think about tracking this as part of your continuous delivery workflow? So with Code Pipeline, I had mentioned that we give you the ability to have custom actions. And I actually already described one of them today. So I talked about how we have an open source plugin for Jenkins that allows Jenkins to talk to Code Pipeline. The interface that uses is actually just a generic API for custom plugins. So you yourself can actually write custom software to talk to Code Pipeline the same way that plugin does. And actually, with all of the other third parties that we have, they're using that same interface as well. So it's very easy to get started with writing your own customizations to integrate with Code Pipeline. The other way is via Lambda. So again, I had mentioned that with Lambda, you could run almost anything that you could think of as part of your pipeline. So again, we try to offer up a lot of flexibility inside of your ability to do continuous delivery and to automate your process. And so what I have here are just a couple of examples of things that you might think about doing as part of your continuous delivery process. So in closing here, we've gone through a number of different things about continuous delivery. What I really want to help drive home is the idea that continuous delivery as a practice pays off inside of your business very well. By focusing on your delivery process, on the tooling, on the practices. You'll see benefits in terms of not just speed, but in higher quality, in happier developers potentially, and into making the overall process of driving more value into your business much easier. It'll allow you to then get, again, your product in front of your users much quicker as well. So when they have new feature requests or new ideas for you or new things, or maybe they found a bug in your application, by practicing continuous delivery, you can help rectify that much more quickly. Lastly, Code Pipeline gives you, again, a number of capabilities for being able to have a very custom workflow for any type of application that you might be building. And so I encourage you all to take a look at it if you can. Oops. A few months ago, or about a month and a half ago, we released a starter kit for Code Pipeline and Code Deploy. And so you can go to this bit.ly link here. It'll take you to our DevOps blog. And on that page, you will find a CloudFormation template that automates almost everything that I showed you today. It gives you a good starting point for Code Pipeline. I'll let you take pictures of that real quick if you'd like. Oh, it went away, sorry. Okay. Sorry. We have a lot of other resources besides just this. So you can find more resources about continuous integration and delivery, about Code Pipeline and Code Deploy, as well as Code Commit, another service that I didn't get a chance to talk about today, including examples, as well as, again, the starter kit, which might be a little hard to get a picture of here. With that, I want to say domo arigato. Thank you very much for coming to this talk. Enjoy the rest of the day here at the summit, and thanks again for coming.
クリスマンスより講演させていただきました。